What is up, my Form 4s? I hope you are having a good day. I hope too you have already viewed my lesson video. Okay, at least one or twice. Okay, make it 3. Okay, so today we are going to talk about questions. Okay, I will try to keep this video as brief as I can. Okay, so I will also upload the answer soon. Okay, so make sure you do it before you check the answers. Okay, all right. Okay, let's begin. All right, question 1. Diagram 3 shows the hypothesis of the mechanism of enzyme reaction on a substrate. Okay, so state the hypothesis. So what is this hypothesis called? Okay, we call it the log and key hypothesis. Okay, do you still remember why do we call it a hypothesis? Because it's not proven. Nobody has seen this before. Okay, but it is the generally most accepted way of enzyme mechanism. Okay, B. What is represented by P, Q, R, and S? So P is enzyme, very simple. Okay, that's my log. So Q is the key, which is our substrate. Okay, our substrate. So what is R and S? Okay, R is my enzyme substrate complex. Okay, enzyme substrate complex. So what is S? S is my product. Okay, in fact, S and T is product. Okay, C. Describe the enzyme reaction based on the hypothesis. So what is this? A hypothesis. So 3 marks here. So the enzyme is the key. Okay, so the substrate, the enzyme is the log, my mistake. Okay, it's the log. Okay, substrate is the key. Okay, so enzyme, okay, substrate will bind to enzyme. Okay, it will form enzyme substrate complex. Okay, I'll write the short form here. Okay, and then the substrate will leave as product. Okay, basically explain the mechanism very simply. Okay, D. State 2 characteristics of the enzyme as explained by hypothesis. Okay, do you still remember we have a few, but the 2 most important ones, number 1, okay, they are highly specific. Like I said, there's only one key that can fit that log. Okay, so what else? They are not destroyed. Okay, not destroyed, or it can be reused. Okay, only small amount is needed to digest a lot of things. Next, E. If the enzyme uses sucrase, so now let's assume this is sucrase. Okay, do you remember what sucrase digests? So Q is my sucrose. Okay, of course P is the sucrase. Okay, how about S and T? Sucrase will split into 2, which is glucose and fructose. This is related to the previous chapter. Okay, if you want to reverse S and T, that's fine. Okay, because there's no specific shape for sucrose or for glucose or fructose. Okay, it's accepted. Okay, let's look at question 2. Okay, diagram 3 shows the reaction of enzyme Y on substrate R. Okay, what is substrate P? I think there's an error here. This is substrate R. So with substrate R, this looks like a sugar, if you still remember. So it could be any substrate. You want to put maltose. Okay, this is a disaccharide, guys. So it can be a maltose. It can be a sucrose. It also can be a lactose. Okay, I accept either 3. Okay, so enzyme Y. So if your case is maltose, this is maltase. Okay, and sucrase, lactase, okay, and so on. So explain process P. Okay, 3 marks. So what is process P? First, name me what is process P. Process P is, the breaking down is called hydrolysis. Okay, hydrolysis. So enzyme Y, okay, or in this case you can say maltase, okay, will break down okay, substrate R, okay, which in this case is maltose, okay, you want to say the enzyme substrate complex, no problem, okay, and then forms, oh yeah, this is 2-glucose here, my mistake, so it should only be maltose. Okay, oh, didn't read the question there. Okay, my mistake. Okay, so it forms 2-glucose. Okay, so 3 marks, very easy to get. Okay, C. So diagram 3.2 shows the stages in the reaction of another enzyme C. So I have another enzyme C, okay, substrate A, enzyme substrate complex product. So this is substrate B, there's another substrate B there. So explain why C only acts on A but not substrate B. Very good question. Because the shape doesn't fit, okay? So can you write it this way? Okay, a better way to write it, you can say, okay, enzyme C, okay, complements. Okay, something is missing here. The active site. Okay, active site. Remember what is the active site? Okay, this is the active site. Okay, so the active site of enzyme C complements the shape, okay, of substrate A. Okay, so you can say the enzyme, okay, can only bind to A, okay, not B. Okay, 2 marks here, very simple. So D, enzyme C is needed only in a small quantity. Explain why. Okay, because C is not destroyed, okay, at the end of reaction. Okay, so when substrate leaves the enzyme, the active site is free to bind to another. Okay, this is like the toilet concept I told you about. Okay, once the thing is out, you can bind to another one. Okay, so E, explain how molecule X affects reaction between C and A. Can you see molecule X is somehow like A, and then this X, they will bind to enzyme C, so now substrate, they cannot bind to the enzyme anymore. This is what we call inhibitor. Okay, so first tell me, okay, X is inhibitor, okay, is an inhibitor. Okay, so it binds, okay, binds to the active site of enzyme C, so substrate A cannot bind to it. Okay, why? Because the active site is occupied. Okay, of course my answer is a bit long, already shorter, no problem. Okay, so shall we look at the next question? Question 3 is almost the same, so let's skip ahead. Okay, let's look at question 4. The graph, just remember this. Okay, so there are 2 enzymes here, enzyme P and Q, and then can you see the optimum pH for P is around 2, while the optimum for Q is around 8 point something. Okay, so basically this is alkaline, this is acid. Okay, so this is pH, you should learn this in form 2. So what is enzyme P and enzyme Q? So what enzyme works in our stomach? Our stomach is acid, remember? So you can say our pepsin. Okay, so pepsin is the protease in our stomach. So what is enzyme Q? Q is the one found in our duodenum. Remember, our duodenum is slightly alkaline because of the bile, okay, the green color bile. Okay, so we can say this is trypsin. Okay, you may say, so what is pepsin and trypsin? You'll learn this in the digestion chapter. Okay, no worries. Optimum pH, this is 2, this is around 8.5. All right, so just an estimate. So B, very good question here. Shows the relationship between enzyme P and concentration of X, okay, at optimum temperature and pH. What does it mean, optimum temperature and pH? Means you don't need to care about these two factors, okay, they are out of the question. Okay, now I'm looking at enzyme and concentration, okay, of substrate. So can you see when my substrate increase, my rate of reaction increase until it flattens at the rate. Do you remember why? Because now who is limiting? My enzyme is limited. I increase my substrate some more, it's not going to increase any further because my toilets are all occupied. Okay, remember my enzyme concentration and substrate concentration, okay, they are the other way around. So based on the graph, it explains how to increase the rate of enzyme P activity when concentration is more than 15. So now it's already more than 15. How do I increase this? Okay, you can say you increase, okay, enzyme P. Okay, or you can say concentration of enzyme P. You put more enzyme inside. Okay, why? Okay, because you have more enzyme P, okay, you have more active site. Okay, so more active site will lead to more enzyme substrate complex, more product. Okay, so higher rate of reaction. Okay, of course you can write the whole thing in exam. Okay, so number 2, if the concentration enzyme increase, okay, so now I put more enzyme inside, draw a line to show the enzyme activity in 2.2. So the graph should look something like this. Okay, can you see it flattens higher because now I have more enzyme. Okay, it's not this, yeah. Okay, a lot of students will confuse, they will draw, oh, the reaction is gonna be faster and stop as no, because my enzyme, I have more enzyme, of course my rate is gonna be higher, and of course I stop at the higher point because I have more enzyme. Okay, I hope this makes sense. Okay, so C, again, the graph, they ask you to describe part P and Q. They only want this part. Okay, they don't want the flattened part, they want the curve going up part. So explain what happens here. So first tell me what happens. So when you increase substrate, okay, you increase the rate of reaction. Okay, the more the substrate, the higher the reaction goes. Okay, why is that so? Because you have higher substrate. Okay, so and don't say more enzyme. My enzyme is constant here. So more substrate will bind to it. So I can form, okay, more enzyme substrate complex. Okay, so more product form. Okay, and so on and so forth. Okay, so number 2, the part RS, okay, which is the flattened part, okay, shows the rate of reaction is constant. Okay, rate of reaction is constant. Okay, sorry for that. Okay, so explain why. Okay, why is it constant? Because now my enzyme is limiting. Okay, limiting factor. So I have limited enzyme means I have limited active site. Okay, I have limited active site. So of course, limited enzyme substrate complex, limited rate reaction. Okay, you can write your full set. Okay, so suggest how to increase the rate reaction from this point. Okay, support your suggestion with suitable explanation. So what do? You increase the enzyme, okay, like I mentioned previously. Okay, increase enzyme. Okay, why? Because you have more enzyme, you have more, okay, more active site. Okay, so 3 points here you can easily get all. Okay, so let's look at one more question. Oh, this video is getting a bit long. Okay, so question 5, this shows oh, this is my sewing machine story. So name structure S. What is structure S? S is going out, so this is what we call secretory vesicle. Remember, vesicle is the bag, secretory means it's going out. Okay, I'm secreting. So B, match the organelle P to its function. Okay, so P, what is this? P is my rough ER. So what is this for? It transports synthesized protein, not site of synthesis protein. This is for ribosome. Okay, how about modifies? This is Golgi. This is chapter 2 stuff. Okay, very simple. Describe the role of organelle R. So what is the function of Golgi? Okay, so it receives protein from ER, from rough ER. Okay, rough ER. Please don't say RER in exam. Okay, please say rough ER. Okay, and then it modifies. Okay, Okay, packages. Okay, and so on. Okay, and then it makes it into secretory vesicle. Okay, basically your packaging guy in the factory. okay, to put the labels on the t-shirt, to package them nicely. So number 2, explain one characteristic of tea which is related to its role in a process described in 2C1. So where is my tea? So what is tea? Why is tea folded? Okay, so what is tea folded? Okay, it is, they want you to say folded. Okay, explain. Please say the characteristic first is folded. Why is it folded? This is to increase the total, okay, surface area. Okay, this could very likely be in your intestine. Okay, because I have more surface area, I can excrete more enzyme faster. So D, beef and fresh pineapple are commonly cut into small cubes. Can you see? Okay, last time I say papaya, this is pineapple. Basically, it's the same thing. Okay, cut into small cubes, mix together and left for an hour before cooking at 37 degrees. Okay, why is it 37? Think about it. So explain why this method is effective in softening the beef cube. So pineapple has what enzyme? If you don't know the enzyme, never mind. You can just say protease. Okay, last time papaya has papain, but pineapple, you don't know, never mind, it's not your problem. Just say protease. So, protease do, it will break down, okay, or you can say hydrolyze, okay, the protein in beef. Okay, so it becomes more tender, okay, softer, okay, or whatever. Okay, so number 2, why must the beef and pineapple be placed at 37 degrees? Why 37? Because that's the optimum temperature for protease. Okay, so number 3, explain why mixed beef cube and pineapple should not be placed in the refrigerator. Why not place, when I marinate stuff, why don't I place it in the refrigerator? Because refrigerator has low temperature, okay, which is not optimum, okay, for protease. So not optimal, what happens? So it will have a lower rate of reaction. Okay, very simple. So E, why are apples that have been boiled after they are peeled do not change color to brown? This is a very good K-But question. So do you know when you cut apple, you leave it in room temperature for a while, it turns brown? Because why? This is something related to your enzyme again. So apple has a type of enzyme, it will oxidize it to brown. After cooking, can you cook enzyme? No, enzyme is a protein. When you cook protein, it becomes, what's the word? Denatured. Again, denatured means the protein is spoiled. Okay, so after cooking, okay, or high temperature, okay, enzyme in apple is denatured. Okay, denatured. Please don't say spoiled, please don't say broken down. Not accepted. It's denatured. Okay, so it's denatured. So does not, okay, oxidize, okay, color to brown. Okay, you can say, there's absence of enzyme, okay, it doesn't break down this thing to brown, okay, or whatever. Okay, F, if you are a food entrepreneur, suggest an enzyme can use to process meat and fish. State the function of this enzyme. So meat and fish is protein. So to break down protein, of course, you need protease. So the function of the enzyme, to hydrolyze protein. Okay, or to break down protein, same thing. Number 2, discuss how the characteristic of enzyme can influence its action. So how many characteristics I mentioned just now? 2. Number 1, they are highly specific. Number 2, they are not destroyed. Okay, or they remain, or you can even say small quantity. Okay, not this. Okay, never mind. I'll talk about this later. So they are not destroyed. So explain. So 4 marks here, 2 marks for this, 2 marks for explanation. So how can it influence its action? So specific, how does it influence it? Okay, they can only, okay, hydrolyze one type of substrate. Okay, one type of substrate. So they are not destroyed. So what does it mean? Okay, you only need small amount. Okay, because I can reuse. Okay, I can reuse my enzyme. Okay, I can reuse the enzyme. Okay, so simple. So I think this video is long enough. Okay, I said I want to keep it short, but I can't do it. Okay, so the other questions, and there are not many, okay, I'll leave it up to you to do. Okay, the t-shirt one already talked about this in the notes. Okay, so use some time and finish the exercise. I'll upload the answer. Please finish it before you check the answer. Okay, since there are no homeworks now, okay, make use of your free time. Okay, play less game or hang out less. Okay, make use of your time. Okay, so that's it for today. Okay, this thing is supposed to be week 3, sorry, week 4. This week is supposed to be April week 1, so I will put the week 1 lesson by hopefully end of this week. Okay, so we will go into a new chapter, which is chapter 6. Okay, it's a bit rushing, but no choice. Your syllabus is pretty damn long. Okay, so I hope this video is helpful. Okay, if you have any question, again, please ask in the group. Okay, and I will see you again this week. Okay, bye bye.